Hi. Now let's learn about the libraries which are going to help us calculate descriptive statistics using Python. So one of the library we are using is pandas, which helps us bring our data into the Python environment in the format of a data frame. We also use matplotlib, which gives us the interactive visualization such as line bar and scattered plot. NumPy gives us access to multi-dimensional array and matrices along with some of the very important mathematical functions. Same way, statistics and math libraries also give you access to many of the statistical and numerical uh, and mathematical functions. So I have already read this data set into the data frame, and the name of the data frame is df underscore shoe. We have 242 rows and we have seven variables to work with. One of the simplest way you can calculate measure of central tendency and variability is just mention your data stream name. Then after dot, you mention your function. Like in this case, df underscore shoe dot mean, then bracket, and df underscore um, median and bracket, and then mode, or same way you can use var and string. So this is one of the very simple ways you can calculate particular measure of central tendency or variability, any measure of descriptive statistics using simply this one, two phrases. But when you run this, you will get a warning. So you have to, one of the very simple way to get away with this warning, uh, use these mathematical or scientific mathematical or statistical functions using this argument numeric underscore only, and set this as a true. When you run this, let's do this for median. You will get no warning and you will get the function applied to only numerical variables of the data set or data frame. You can also do another way is to get the particular function run only for the variable in which you're interested is. Like in our case, in this case for mode, I have run the mode function only for the shoe size variable, and and assign this result to a variable mode underscore size. Let's run this and see what we get. We get the mode, which is 5, and that means 5 size shoes are the most sold size of the shoe in the last in the analysis. This gives you answer to the problem, which size of shoe are mostly sold. So that is 5 number, and we can take our decision based on this information. Let's do one more. Let's run this std function also and see what we get. So you can, the spread of this shoe size is 2.47. That's our standard deviation for this particular variable. Let's plot a simple graph first. Let's run this. Uh, Simply data frame name, then function is plot. On x-axis we're plotting style, and y we're plotting sale number, and we are plotting a bar graph. But when we run this, you will see this is not the output we're expecting, because this is going to plot all 242 rows for each style and each sale number. This is not something the correct way of performing this analysis. So we are going to use a function which is group by. So what we are going to do, we are going to get the count of sale for each type of style using this function. So this part of the code, which is df shoe dot group by of style, this gives you the groups of the data frame by the style column, and uh, sale number dot count gives you the sum of the sale number count of the variable within each group. Let's run this and see what we get. So now you can see the most sold style uh, a shoe is running shoes. Now let's plot this quickly and see what we get. The correct graph. So now we know which uh, which type of style has been sold how many times from in our data. Happy learning.